Hi folks, this is your Wednesday maths video and our learning target for today is to calculate angles in a straight line. So we're going to be using the knowledge that you've already acquired this week and going to be applying it. Okay, now we've got some really lovely questions here, including some great reasoning and problem solving type ones that you will really like. So let's get going. Right, let's have a quick recap. We're going to need to know this before we start on today's work. So we should know that a straight line is 180 degrees. We should also know that a right angle is 90 degrees. And there would be two right angles in a straight line. So two 90s is 180, and if you put two right angles, that would be the same as a straight line. Right, if you are confident with that knowledge, then you'll be ready to start on today's questions. So let's have a little look at this one. This is typical of the first questions that we've got today. So we've got a straight line here at the bottom, and we've got one angle here, and we know the measurement, we know the size of this angle. And what we want to do is we want to find the size of this angle. Now, we're not using a protractor to do this, we're going to use calculations to do this. So let's have a quick look here. You know that a straight line is 180 degrees, so the whole of that blue angle would add up to be 180 degrees. That whole of that semicircle there is 180 degrees. You know that if you had a right angle, that would be 90. So when you're looking at this, you should be able to see that the size of x is less than 90 degrees. It's less than a right angle. But you can also see that x is bigger than half a right angle. Some of you are finding that. You're finding that on Sunday, a half a right angle, which would be 45 degrees. We know that this section is 100 degrees. We know that angle there. And we know that the two angles, so those two blue angles, are going to add up to be 180. So you need to use all that knowledge to work out x. Some of you might be already telling me how to do that. Let's have a quick go with a good old bar model as well. So if we know that the total for that straight line is 180, that's represented on that top bar, we already know one angle, we already know that that's 100, and we need to know this. This is what we're trying to work out. So this bar model really nicely represents 180, take away 100 will give us this. Yep, those two angles, those two numbers, would add together to make the 180. So it's a nice bit of inverse there. Some of you might see that a bit clearer with that bar model. So here are our questions for today. These first ones, using what we've just had a go with now, we've got 180 will be the whole of that straight line. If we already know 33, we're going to do 180 take away 33. This one is the same. The straight line would be 180. So if we take away the angle that we know, we'll be left with the missing angle. A good way of checking these ones is once you've found your missing angle, it's adding those two angles, and they should add back up to 180. So these ones are all the same. You've got one angle given, and you're doing it as a subtraction from 180. Right, this is a really lovely question, okay? But just going to go through it with you so that you know what your answer should look like. So it's got three statements. It says, read these statements and decide if they are always, sometimes, or never true. So you've got three different statements to do here. So three bits of the question here. This is really important. Be sure to explain yourself too. So the first one says, two acute angles next to each other make an obtuse angle. Half an obtuse angle is an acute angle, and 180 degrees is an obtuse angle. So for each one of those, you need to decide whether that is sometimes true, always true, or never true. And the way that you're going to do it is you're going to start with one statement at a time. So you've got to decide if it's always, sometimes, or never true. To do this, you need to try it out with at least two examples. So choose some numbers. So for the first one, two acute angles. So choose two numbers that would be an acute angle. Okay, that's going to be less than 90. So try any two numbers and see what they add up to. Okay, do they add up to an obtuse angle? Try that at least twice. Look at the answers that you get for your examples, and do they show that the statement is always true, sometimes true, or never true? Okay, now when you do this, we need evidence. We don't just want to see sometimes, never, always. Okay, you need to show us. Yep. So you need to give at least two examples, which are those two examples from there, of evidence. So if it was that you think it's sometimes true, you'd need to show one example where it was true and one example where it was not true, and that would show that it's sometimes true. Okay, so really important on this one is you're going to need to answer those questions. You're going to need evidence. You're going to need to kind of prove to yourself. When you've got those examples, make sure you include them in your answer. This is a really lovely question, and it will really get you thinking as well. Okay, this one is a little bit trickier. We're doing the same thing. Okay, so our angles are all going to add up to 180 because they're all on a straight line. But instead of like the previous one where we just had one angle we were given and we needed to find the missing angle, this one, there are several angles given and we've got to find the missing one. So, for example, with this one, you're going to have to add up those three numbers. Once you've got the total, you'll then have to subtract that from 180 and it will give you this missing one here. Okay, again with this one here, add up the two that you've got, subtract those from 180. This one's a good one. Okay, it's given you two angles. Remember that if it's got a square in the corner, not one of those curved arches, it's a right angle. And you'll have to remember how many degrees in a right angle to work out that missing angle Z. Right, last one. If you want a bit of a challenge today, oh, not that. There are two optional extensions, so you don't have to do these, but this is a really good way of applying what you've learnt, so really testing how well you understand it. We've got two questions. The first one is Jack. He's giving you some information and you've got to explain why he's wrong. So he's telling you something which is not right. So read through all the information, spot what he's done wrong. Right, this one is lovely and it is tricky. So this one needs resilience for sure, but all the clues that you need are there. So same thing again, you've got to work out E, F and G. The clues that you need to work them out are here, okay? So you've got to see if you can calculate the size of the angles. Show us any working out if you do it. This is definitely doable, but you've just got to focus and use those clues. So those clues might need to be used in a different order. So work out which clue is the one that you need to use first, and then you can go from there. Really lovely one. So some of you, if you're up for a challenge, this might be something you leave till Thursday if you run out of time today, but it'd be really lovely to see as many of you as possible having a go with that one.